Welcome to Study Loop.
We need to find the two different sag values, H, that this cable can take on whenever there's a given tension of 350 newtons at this point B. So to start, we're going to first find what the weight per unit length of this cable is, since we know what the mass per unit length is. So this weight per unit length is going to be equal to the mass per unit length times the acceleration due to gravity. So the weight is going to be equal to 3 times 9.8, and we'll get a weight per unit length of 29.43 newtons per meter. And now the equation for the length YFB, that's going to be equal to the tension divided by the weight per unit length. So now we can say that this length YFB is equal to 350 divided by 23.43, and that's going to give us a length of 11.9 meters. So we're now going to say that this y of b, let me write this in blue. So this y of b, we know is also equal to the length c times the hyperbolic cosine of the length L divided by 2 divided by c. So we can plug in y of b here, and we can also plug in L as given by the problem. So we'll have 11.9 is equal to the length c times the hyperbolic cosine of L, which is 6, divided by 2, divided by c. And solving this equation for c, we'll get two different values for c. So we'll get a c value c1, which is equal to 0.93 meters. And we'll also get a c value c2, which is equal to 11.506 meters. So now, to get the length h, so this length h is what we're trying to find. We can say that length h is going to be equal to y of b minus the value of c. So we can plug in c1 first. So we have h is equal to 11.9 minus c1, and that will give us a length of 10.97 meters. And now we can plug in c2. So we'll get that h is equal to y of b minus c2. And that will give us a length that's equal to 0.394 meters.